Today we are going to see the designing of Boolean function by gate level method. That is one of the method. In the previous class also we have seen the Boolean function designing by using two methods. One is truth table, second is hardware, that is logic gates. The logic gates, one more name what we can call it as, we can call it as gate level method or gate level designing. So let us consider different examples in order to understand in a detail wise. So for example, they gave one Boolean function. So suppose we had the function f1 is equals to x y bar plus x bar y. So we need to design by using two methods. First method would be our truth table method. In truth table method, what we'll do, we'll try to find out its truth table by taking this function. So in this, what we are taking two different functions, since it is what, it's a function of two variables. So in order to do this one, what we'll do it, we'll take x and y. Since it is two variables, so we can find out by taking x and y. So we'll take x and y. So since it is two variables, we can take the combination 0 0 0 1 1 0 and 1 1. So this is the two inputs. The next thing what we required is, we required x bar. So we'll take x bar value. So what is x bar? If it is 0 0, it would become 1 and 1. If it is 1 1, it will become 0 and 0. Similarly, next thing I need to take it as y bar. So for finding the y bar, what we'll take it? We'll take, if it is 0, it will be 1. If it is 1, it will be 0. So like this, 0 means 1. So 1 means 0. So we found x bar and y bar. Next thing we need to find out x multiplied with y bar. So we can write x into y bar. So we are writing over there x into y bar. So what is x value we had? We had, this is our x function. So we are taking x, this column, and next we had y bar, this column. So we'll take both of them and we'll write its function. So for writing this thing, what we'll take? We'll take x will multiply with y bar. So 0 into 1, it would be 0. 0 into 0, it will be 0. So 1 into 1, it would become 1. Then 1 into 0, it will become 0. Similarly, next term we need to multiply with x bar with y. So we can write x bar. What is x bar over here? We had x bar here, we had y here. So we need to multiply both of them. So we'll write both of them. X bar into y, it will become 0. So 1 into 1, it will become 1. So 0 into 0, it will become 0. 1 into 0, it will become 0. Then at the end, what we need to do? We need to write its function. For writing the function, what we'll do it? We'll take x y bar plus x bar y. That is nothing but I can write directly as f1. So f1 would be addition of these two terms. Term 1 plus term 2. If you combine both of them, we can write its function over here. So we can write, add both of them, 0 plus 0, it will be 0. 0 plus 1, it will be 1. 1 plus 0, it will be 1. 0 plus 0 again, it will be 0. So this output is similar to the function of x exclusive OR with y. So we will be having one logic gates. So in this, what we are going to write? We are going to write x exclusive OR with y. So what is exclusive OR? It is a special type of gate. So in this, what is the truth table of exclusive OR gate? It is like this. If you had two inputs, A and B, if I want to write the A exclusive OR with B, so what is exclusive OR symbolic representation? This is the OR. We are writing exclusive OR. So I am giving the input as A and B. So A exclusive OR with B. So we'll take the combination 0 0, 0 1, 1 0 and 1 1. What is the exclusive OR condition over here? Exclusive OR states that if both the inputs are different, then only output is high. So see, both the inputs are different? No. Both inputs are same. So we can write output will be low. So both the inputs are different? Yes, it is different. So output will be high. Similarly, both the inputs are different? Yes. So the output would be high. So now both the inputs are different? No. Both the inputs are same. It can be 0 or it can be 1. But input needs to be different. So here inputs are same. Again it will be low. So that's how this truth table exclusive OR and this truth table of that function both are same. So that means we are verifying x y bar plus x bar y is similar to the x exclusive OR with y. So that is one of the first special gate. Similarly, if you want to design the same function by taking the gate level, so this we are doing by using truth table. The same function we can design by using the hardware part. So in order to do the hardware part, what we'll do it, we'll try to write this one in terms of hardware. So how to do it? In order to do that one, what we'll do it, we'll take vertical approach. What is a vertical approach? We know it. So vertical approach of gate level designing or gate level design. So what we can write, since how many things we had? We had only two inputs, x and y. So what we'll do it, we'll take two vertical, what we call vertical lines, we'll put it, and we'll mention the name as x for the first one. For the second one we'll mention as y. Since we required complement, that is y bar and x bar, both are complements. So what we'll do it, in order to get the complement, we need to connect one NOT gate. So this is one NOT gate, this is the another NOT gate. So we got both the NOT gates. So we need to write its output would be x bar over here and y bar. Next thing, we have to multiply this one and this one. So in order to multiply this one, what we'll do it, we'll take x value and we'll try to multiply with y bar. That is the first connection. So since we are multiplying, we need to connect with one AND gate. Likewise, we had the second term. In the second term, what is given? X bar with y. So what is x bar with y? X bar means this is the connection. X bar is there. Then we had the next connection y. So we'll take one more AND gate. So what is the output for the first one? We can write, since we are connecting with x. So whatever the dots we are putting, that is resembles its connection. That shows that gate is connected to that specific part. So here x is there, here is y is there. So x with y bar, that is the first one. Similarly, second one, we had x bar and it is going to connect with y. So we can write x bar with y. So both are AND. Next thing, we need to add this thing. So in order to do the addition, what we'll do it, we'll try to connect with one OR gate. This is our OR gate. That complete function is nothing but the F1. So in the F1, what we'll do it, we'll try to write its function x and y. We got the output. So see here students, so we have designed a special gate that is nothing but the exclusive OR gate by using its truth table and by using its logic diagram. So in this, what actually we understand that whatever the function, so that function they give, that is x y bar plus x bar y is equivalent to x exclusive OR with y. So that special gate, the basic gates when I explain you, I've explained only NOT, OR, AND. And we decided about NAND and NOR. So in this today's class, we are going to see this exclusive OR gate, its total resemblance, that is called nothing but verification. Both the things we have seen, its truth table method and its hardware, vertical approach. In the exam, if they ask you for, this is an important question, in exam if they ask only design it, so we need to go with this one. If they ask to verify it by using truth table, so we need to go with this part. So anyone, they can ask you or else they can ask both of them. That means you have to verify by using truth table and you need to write its vertical approach. So let us see the next part, that is exclusive NOR gate. How the exclusive NOR gate can be designed, let us see. So students, we have designed one special gate, that is first thing is nothing but exclusive OR gate we have designed. And what we can conclude from exclusive OR gate, we can conclude that if you had two inputs A and B, if you want to write the output of exclusive OR gate, A exclusive OR with B, we can take by taking, if you had two inputs 0 0, 0 1, 1 0 and 1 1. If I do have this thing, if I want to write its output, what I can write? I can write if inputs are different, then only output is high. That means this has become 1, this has become 1. Since inputs are different, we can write output is high. And if inputs are same, then output would be 0. Similarly, the next type of gate is exclusive. That is the first part, exclusive OR. We are going to the second part in that special gate, that is nothing but exclusive NOR. So what is exclusive NOR? truth table, exclusive NOR, truth table. In order to design this one, first we'll try to verify the function. We'll take Boolean function f is equals to, or f2 is equals to x bar y bar plus xy. First thing, we'll see this one. Then we'll see its complete exactly exclusive NOR. What is exclusive NOR symbol? X, exclusive NOR with y. Over there, we'll write plus sign that indicates exclusive OR. If I indicate dot with circle, then it shows that it's nothing but exclusive NOR. That is exactly equivalent to this one. Now, how we are saying this is exactly equivalent to this one? Let's see its truth table. So, what we'll do it? In the same way, we'll take two inputs, x and y. We'll write its x bar, then we'll write its y bar, then we'll multiply with x bar y bar, then we'll multiply x into y. Then at the end, we'll add x bar y bar plus xy. So that's how we'll design its complete truth table. Okay, so what we'll do it? We'll take inputs value 0, 0, 0, 1, 1, 0 and 1, 1. Next thing, we need to write complement of x. So what is the complement of x bar? If it is 0, 0, it would become 1, 1. If it is 1, 1, it will become 0 and 0. Similarly, go with y bar. So in y bar 0 is there, that means 1. 1 means 0. 0 means 1. 1 means it's 0. Next thing, we need to multiply x bar with y bar. So x bar multiply with y bar, 1 into 1 it will be 1. 1 into 0 it will be 0. This is also 0. This also 0. Because multiplication means both are high, then only output is high. Go with x and y. What is x and y? 0 into 0, it will be 0. 0 into 1, it will be 0. Again, 1 into 0, it will be 0. 1 into 1, it will be 1. So we had both the terms. This is the term 1 and this is the term 2. So in order to do this thing, term 1 plus term 2 will get the R function. So what we'll do it? We'll add this thing. 1 plus 0, it will be 1. 0 plus 0 it will be 0, 0 plus 0 it will be 0, 0 plus 1 it will be 1. So we got this thing. Now try to write its truth table. What is the truth table of exclusive NOR gate? Exclusive NOR states that if you had two inputs A and B, if I want to write exclusive NOR is complement to exclusive OR. What I will write? If I do have 0, 0, 0, 1, 1, 0 and 1. Exclusive NOR states that if both the inputs are same, both needs to be either low or either high. So if both are same, then only output is high. So see, 0, 0, that means both are same, it is high. 0, 1, it will be 0, 1 means both are different, it will be 0. 1, 0, it will be 0. 1, 1, both are same, then only output is high. So what is the circuit symbolic representation of it? So we can represent over here, if you have A and B, exclusive NOR, we are want to write exclusive OR is this much. But since it is exclusive NOR, we need to put a bubble over here. So what is the output of this A exclusive NOR with B? What is the exclusive OR we have seen? Exclusive OR symbol will be one line we need to put it and we need to write over here like this, A and B. So what is the output for this? A exclusive OR with B. So this truth table and this truth table you can see. So these are what? Special gates. One is exclusive OR, second is exclusive NOR. So in this, what is the conclusion we can write? We can write that if inputs are different, then only output is high. Whereas over here, what we can write? If inputs are same, then only output is high. So these two gates we have seen. So in this, if they ask to write with truth table, we go with this part. If they ask to design with the hardware. So what is the hardware part? We'll do it. We'll try to draw its hardware approach. So what we'll do? We'll take two inputs. Like this, we'll take it. What is the name of the first input? X and Y. And if you want to connect with NOT gate, it will become X bar. One more if you want to connect with NOT gate, again it will become Y bar. So we got X bar and Y bar. What we need to do it? We need to connect with one AND gate. So we require two AND gates. So we'll directly write over here like this. So we'll write this thing. We had X bar and Y bar. So we take a connection from, first connection is from X bar, second connection is from Y bar. We took it. Second thing, we need to multiply X and Y. So we'll take one input from X. Second, we need to take from Y. So we have took. Next, since it's addition, so what we'll do it, we'll try to connect with one OR gate. So we are connecting with one OR gate. So this is our output function F2. So that's how this truth table and its hardware by vertical approach we have designed. So that is what it is considered to be the special gates. In this thing we are taking gate level method. So in gate level method, what actually we have seen? We have seen complete its truth table as well as its vertical part. Now we'll take different functions. In the second approach, we'll not proceed with this truth table because you all are familiar with truth table now. Next thing, by using some theorems, that is called Boolean theorems, we'll take it and how these functions, the Boolean expressions can be modified and how we can take by using the vertical design, or we had one more method that is a horizontal design. Both the things I'll explain you in the next video. Thank you. Now see students, so we are taking two Boolean function. F1 they gave you, F1 is equals to F1 of, there are three variables in it. One is A, B, C. That means we required, by seeing this thing what we can conclude? We can conclude that it required three inputs. That means we need to take three different vertical lines. So since if you are proceeding with vertical hardware approach, so we have to use 3 ABC. So in this expression they gave you A bar B plus AB, then whole function we need to multiply with ABC. So this thing they asked to design by using gate level method, or what is the one more name for it? That is nothing but gate or hardware. So both our meaning is same. So this thing we are using and we need to design by using vertical approach. Similarly in the second function F2 of A comma B comma C, in this again it is three inputs, so we can take three variables over here. So here we had A bar BC plus A B bar plus C. This whole function we need to multiply with A bar with B. So what we'll do it, we'll take first three inputs. So this we are saying it is A, this is your input B, this is your input C. So what we required, only required with A bar. A bar means we need to use one NOT gate. So we are using one NOT gate because in the expression only we required NOT gate, or else if you want to draw the NOT gate, as per that you can do it, but there is no connection for NOT gate. So this is up to your option that whether you want to draw the NOT gate for B and C, you can draw it, but there is no connection with B and C because we don't have any complement for B and C. First thing we had A bar B. So what we'll do it, we'll take one connection. We'll take, this is your A bar, right? So we'll take one A bar input and that should be multiplied with B. So this is our B input. So we try to connect with one AND gate. That is the first expression. Second term over here we need to multiply with AB. So we'll take with one A. Second we'll multiply with B. So again we'll try to connect with one AND gate. This two, A bar B plus AB bar, what is the value over here? We had A bar B over here, this we had AB. So these two things what we'll do it, we'll try to draw with plus sign. So plus indicates what? It's indicate OR gate. So what we'll do it, we'll connect these two inputs with one OR gate. Clear? So this thing we did. Next thing what we need to do, we need to multiply this whole thing. What is the output here? So we can write over here is A bar B plus AB. This thing we did. Next thing is that we need to connect with one AND gate. That AND gate we need to again multiply this whole expression over there. So what we'll do it, we'll take A input, we'll take the B input, we'll take the C input. So these three things we need to multiply. So what is the output over here? This is A, B and C. So since we are multiplying, so what is the first input we had? We had A, we had B and we had C. These three things we had. So next we need to again multiply. So this function input and this input function will multiply. So multiply in the sense we need to connect one more AND gate. So what is the output over here? We can write that is a whole function F1 is equals to, so what is here till here? A bar B plus AB. This whole we are multiplying with ABC. So that's how our function F1 function can be written in this format. Next, similarly, if you do have F2 value, so in this F2 also we had 3 inputs. So as per this, what we'll do it? We'll ABC. We'll take ABC value. So as per that, we'll take logic design for it. We'll take A, we'll take B, and we'll take C. So what is the first name we can give? We can give A, B, and C. Next thing, we need to multiply with A complement. That means one NOT gate of A is required. Second thing, one NOT gate of B is required. Thus 2 things only is required as per the given Boolean function. But if you want to draw for C, you can go ahead with C. There is no problem with that. You can do it, but there is no connection with C bar over here. So what I'm doing? I'm taking one NOT gate. So I'm connecting with one NOT gate. One more NOT gate I'm taking. One more NOT gate I'm taking. So this is the layout. This is the just hardware layout we have designed. Next thing, we need to go for first term. So what is the first term over here? Since it's A bar, this is your B bar, and this is your C bar. So what is A bar, B, C? So we'll take A bar connection, second B connection, next is C connection. So this 3 we have taken, we connect with one AND gate. Next thing, A with B bar. So we take A, this is our A value, with B bar, this is our B bar value. So we connect with one more AND gate. So this term is done. Only what is required? Plus is here, plus is here. So either way, you had one term, you had second term. Only required one more C. What I'm doing? I'm taking the connection from C. This way. And these 3 things, what is the value we had? These 3 functions we are connecting with one OR gate. This is our OR gate. So this is total output of this one till here. It is what is the value? A bar, B, C. Next term, A, B bar. Here is C. So what is the value over here? A bar, B, C plus A with B bar plus C. Next thing is that we need to multiply with A bar with B. So we should not proceed with this thing. First thing we need to do for A bar, B. So what we'll do it? We'll take A bar. So this is our A bar. Next thing, after taking A bar, next thing is that we need to take with B. So this is our B vertical line. So we'll connect with one gate. So what is our output of this? A bar with B. So this thing, this input and this input. So this 2 we had. So what we'll do it? We'll have to multiply this whole expression, this term and this one. This we need to connect with one more AND gate. That is the complete function F2. So F2 will be equals to this whole term. What is the whole term here? We had A bar B C plus A B bar plus C multiplying with A bar with B. So as per this, you need to write the analyze. What is the analyze in this? What is your analyzing in the whole thing? We need to write in statement form. After knowing this designing part, how many gates you required? The first thing, as per the requirement, first thing what you need to write, we required the procedure for it. We required 3. This is our optional, this is our optional. So we can write one NOT gate is required, 3 AND gate is required, 3 not, 4 AND gate, because here also we are using. So 1, 2, 3, 4. So 4 AND gate. Next thing is what? One OR gate. So this is the complete, which approach we are proceeding. This is nothing but the vertical method or vertical approach of designing. This is also vertical way. This is also vertical way. We have designed our Boolean function. So for this expressions also we are using how many? As per the question we require only 2 AND NOT gate, 1, 2, 3 and 4. 4 AND gate and 1 OR gate. So this is the way we can design our function for these 2 Boolean values. I'll give some questions to solve at home. Based upon these 2, I'll give some problems, just 3 to 4 problems I'll give you. Try to proceed with this way, vertical approach, and second, this 2. This way, you try to do with truth table also. Go for this truth table, these 2 problems. I'll add more 2 problems. Do with truth table and with this hardware and send me on mail. So take these questions for homework. The question is implement the Boolean function. by using the truth table and hardware gate level design. Hardware, or the name for that would be gate level. So design. So what the first function for this would be f1 is equals to a complement with b plus a b plus a bar with b bar. So this is the function we had. Second function f2 of a comma b comma c. In this, a complement with bc plus a b complement with c plus a b c complement plus abc. So this is the second function. Next, third would be f3, that is a boolean function of a comma b comma c is equals to, we can write a b plus a bar b bar plus a b bar plus a bar b. So this is the three functions we had. So this thing is that we need to go for truth table, and then we need to go for its gate level designing. So in truth table we require only two inputs, means only two input truth table you need to design, and you need to proceed with the first function. For the second one we had three inputs. So based upon these three, what is the first function? We had a b, a bar b c plus a b bar c, then a b c bar plus a b c. So for this thing again you need to go for truth table, since it is three inputs, it required three variable. So that three variable you need to do it by using this function. Next thing f3 is given with abc. So in abc what we'll do it, we'll take ab plus a bar b bar plus ab bar plus a bar b. So this they gave you need to go for truth table, and you need to verify that this third function, the output, if you verify the output by truth table, at the end what you'll do it, after simplifying the whole, if you had a b like this, you need to go with whole function, last column the whole output should be 1 1 1 and 1. So whatever the part you need to do, at the end you need to verify this output. That means if you're simplifying the whole function, last must be high. This thing you'll try it. If you won't get, I'll show you in the next class. So have a good day. Thank you.